Good day, students. Today I want to solve problem that deal with Pascal principle. What is Pascal principle? Pascal principle states that the pressure applied to an enclosed fluid is transmitted undiminished to every portion of the fluid and the walls of the containing vessel. Example is when you applied air pressure to a bicycle tire. The pressure increased to every portion of the tire along the tire. Okay, and also is being applied in a hydraulic press, motor car brake. Now let's analyze it. Let's analyze the hydraulic press. This large piston. Okay, you now have it being connected to a cylinder. And you have the small piston. The small piston is here. This is a small piston, and it's been connected to the large piston. There's a fluid here. Okay, the large piston. When you apply the force on the small piston, it pulls the fluid to the large piston, and this is the force being applied, and this one will now go up. It goes up. It goes up as you're applying the pressure, and the fluid moves. It pushes it up. Okay, now let's analyze the question. The radius of the large cylinder of an hydraulic press is 20 centimeter. You can use R to show that it's RL equals R1L equals 20 centimeter. 20 divided by 100, you have 0.2 meters. And that of the small cylinder, R2 small. But the second one, that's why I put 2 to be 5 centimeter equals 5 divided by 100, 0.05 meters. And if a force of 100 Newton is applied on the small piston, small piston, that's force, F2 small, that's 100 Newton. We have to calculate the force on a large piston, F1 large. We don't have it. Okay, and if the piston of the small cylinder moves through a distance of 0.4, you can put D small, 0.4 meters. You have to, through what distance can the load of the large piston be raised? That means that if you push it and it goes down with distance of 0.4 on this small cylinder, for how much distance could the large piston be raised? Because it will be raised concurrently, but let's know by what distance. Now don't forget that pressure equals force over area. Okay, now let's look for the force first. We are going to relate these two together, force over area. But let's get the area first. Area, which is for the first one, area is pi r squared. That's the formula for area. But we now use, why do we use pi r squared? Because we are dealing with a cylinder. It involves the circumference, which is area of a circle is pi r squared. That's why we are using pi r squared. Now let's deal with for the small cylinder, for the small piston, which is, we are going to say pi area now for the small piston. That's pi r 2s squared, which is pi is given to us 3.142. R2 is a 0.05 squared. You square this and multiply by 3.14. When you do that, you have 0.007855 meters squared. Now, area of the large piston, that's pi r1 large squared, which is 3.142 times the radius of 0.2 squared. When you press your calculator, you have 0.12568 meter squared. Okay, and what we need to do now, we now go back to the formula for the pressure. We now use F1L for the force of the large over the area of the large, equals F2S. You can see, over area of the small. Okay, now what do you get as F? We are looking for F1L over area of the large, 0.12568, equals force of the small, which is given to us F2S, 100 over area of the small, 0.007855. You cross multiply. When you cross multiply, you now have 0.007855 F1L equals 100 times 0.12568. Divide both sides by 0.007855 by 0.007855. Cancel out. You have F1L, force of the large. When you multiply the numerator, you have 12.568 divided by 0.007855. When you press your calculator, you have 1600 Newton. Okay, 1600 Newton. Okay, the second question now says, what distance can the load of the large piston be raised when the piston of a small cylinder moves through a distance of 0.4? When the piston of the small cylinder moves through 0.4 meters, the volume of the volume of the fluid that moves is as follows. Okay, don't forget that you have volume of the small cylinder to be area of the small cylinder times the distance of the small cylinder. What's the area of the small cylinder? You have 0.0007855 times the distance it moves 0.4. When you press your calculator, volume of the small cylinder that moves, the small cylinder that moves at this proportion when the distance of the when the piston of the small cylinder moves through this distance, you want to know the volume of the fluid that moves. When you press your calculator, you have 0.00314 meter cube. Okay, the volume, this volume is now transferred. Look at it, it's now transferred to the large cylinder. This volume that moves through the small cylinder, but now it's now transferred to the large cylinder. We now want to know the distance the large piston can be raised. The distance that the large piston can be raised is, say, distance is ds, which is equals to, don't forget that the volume equals let me write it here. Volume equals area times distance of the large cylinder, but it's going to make use of the volume of the small because it's being transferred to the large cylinder, the same volume, but we now use area of the large. We are using area of the large, area of this large, but its volume of the small is being transferred to the large. Okay, we now use dl, distance of the large, equals volume of the small divided by the area of the large, al. Okay, now distance of the large at which it moves when it's being pushed up, is that okay? Is what volume of the small is 0.003142 divided by area of the large. What's the area of the large? You can see it here, is 0.12568. Okay, when you press your calculator, you have 0.25 meters. That's the distance at which a large piston will be raised. And if you want to convert it to centimeter, 2 multiply by 100, you have equals to 2.5 centimeter. 5 centimeter. 0.5 centimeter. When you multiply it by 100. This is the end of our class. Please subscribe to my channel so that I can have access to the latest video. Have a wonderful day.